Alright, so let's look at 2.9, solving inequalities with one variable. So we're going to learn again how to make a sign chart using values of x where the function is 0 or undefined. We're going to use a sign chart or a graph to determine the intervals where the function is positive or negative. And we're going to try to understand how parentheses and brackets relate to less than and less than or equal to signs when solving inequalities. So back in section 2.3, we graphed polynomials like the following, which is f of x is equal to quantity of x minus 2 quantity squared times the quantity of x plus 3 times the quantity of x minus 5 using zeros, multiplicity, and end behavior. So, done a lot, but we've got some more to go. So, in order to solve f of x is greater than 0, well, f of x is just a fancy way of writing that is a y. Alright, so I'm just looking for where my y value is bigger than 0. Well, my y values are going to be bigger than 0 above my x-axis. Likewise, in order to solve f of x is less than 0, well, my y values have to be less than 0, or below my x-axis. So the fancy way that we're going to say this part is we are going to say that we are going to find the intervals on the x-axis that make your y values positive. And likewise, for this one, I need to find the intervals on the x-axis that make my y values negative. So what I mean by that is it's probably going to end up looking like my domains that we've talked about already. So example 1 says use the graph above to answer the following inequalities. So it says, okay, we need to find the value such that the function is greater than 0. Well, greater than 0, talking about my y values being bigger than 0. And again, that's just when my graph is going to be above my x-axis. So my x values that corresponds to is, well, I'm coming in from the left all the way until I hit my x-axis, which is directly right here at -3. So coming in from the left would be negative infinity all the way to -3. And that -3 cannot be included because at -3 it actually crosses the x-axis, which would mean that my y value would be 0. And since I cannot include 0 on this interval, that does need to be a parenthesis because it does not have that or equal to bar there. And then I don't get to go back above the x-axis until way over here at +5. And then I go up and up and up and to the right forever and ever and ever. And that's going to go towards infinity. Alright, cool. So what about the values of x so that the whole function is greater than or equal to 0? Well, this is going to look very similar, except this time I can actually include 0 on that interval. So I've got negative infinity, which is still never ever ever included, all the way to -3 still. But this time I can include 0. So 3 is where it crosses that x-axis, which means my y value would be 0 there, since I can include 0 this time. As far as my y values go, I can actually include that -3 of an x value. Alright, and then I can actually include my 5 this time as well. And my infinity is always going to go to have a parenthesis. The only weird thing is, I also have this 2, which is also at 0, which I also need to include all by its lonesome self. In between those go 2 unions. Unions just signify that they are going together. Alright, the next thing we got to do is say that function is less than 0, so that's just going to be below my x-axis this time. So my x values, where my y values go below my x-axis, starts at -3, but does not include -3 again, because that's where my y value is actually 0, and I cannot include that on my interval. So that's why I get a parenthesis there. All the way to, technically, 2. Alright, because then I can't include that 2, because at 2 it is actually 0. 0 is not on my interval here. And then it goes back below my x-axis, which is going to be from 2 to 5. And that's it. Signify that those two go together. Let's move on with our lives. On the next one, I actually can include 0, so this can be written a couple of different ways. I can say, okay, I can include -3 this time. 2 for sure. And then union with, since I've already included 2 once, I don't need to include it again with another bracket, 2 to 5. Or I could have just said, okay, I've got -3 to 5. Since I can now include that 2 on that interval. And then with that, I'm done.